Welcome to the project of solar induction motor drive. So here we are going to run this induction motor, which is of 230 volts, 33 watts. So they are the induction motor ratings. And to run this motor, generally from the DC we need to use the inverter. So because any inverter need of constant voltage and constant current source, then only the inverter can convert the DC to AC signal. So without any malfunctioning. So now if we connect the 12 volts 40 watt solar panel to the inverter, it will not work as there is no constant voltage and constant current source from this solar panels. So that's why we need to maintain the constant voltage, constant current. So for that we are making use of this microcontroller section. So in order to run this section, we need to provide the battery. This battery is meant for only to run this microcontroller. So the microcontroller work is, it is going to measure the solar voltage. So solar panel has to be connected at this section. This is the first point. And second connection is we need to connect the total outputs to this inverter section at this C point. Okay, only these two are the main connections. Once we connect the solar panel here and switch on the battery, the microcontroller start reading the input voltage from the solar panel. So when there is sufficient voltage, so then it start converting the means it's improving the currents and buck and boost operations done with this buck boost converter ICs. And after that the voltage will be given to the inverter through the MOSFET. So the MOSFET purpose is in order to maintain the low currents, in order to maintain the low heat up. Is there any high wattage is coming used by this motor, then we are going to control that by using the MOSFET as a switch between this whole boost converter and the inverter. So this is the flow of the whole project. The 12 volt 40 watts will be given to the current boost converter, and parallelly the solar voltage will be given to the PIC microcontroller. So it's going to control the current boost converter by giving the signals to the MOSFETs which are already present at this. So the current boost converter is this one. So it has a double boost converter, so in order to maintain the maximum current. And then after the output of this boost converter is given to the voltage boost converter. This is the voltage boost converter, and same signals given from the microcontroller based on the input voltage from the solar panel. So as we know that buck boost converters operate with the inductor capacitor charging and discharging, and the charging and discharging timing will be controlled by this MOSFET, and the MOSFET get the triggers from the microcontroller. And after that there will be MOSFET circuits as I said here. So after the whole output, after boost converter, we will get the 12 volt to 40 watts approximately power, and that was given from the MOSFET to the CD4047 IC. So if is there any heavy power consumption from this motor, then the microcontroller will isolate the power supply from the MOSFET to the CD4047 IC. And coming to the after getting the power supply from the CD4 MOSFET, the CD4047 will convert the 12 volts DC to the 12 volts AC by using the MOSFETs, and 12 volts AC given for the step up transformer. And after that, as usually, the motor start rotating. This is the process. So there will be two signal generators from the 4047 IC.